Today we will see one of the interesting problem to solve Fourier transform. So here the problem is given, find the Fourier cosine transform fc of e to the power minus x. So before going to solve this problem, we have to understand the problem first, understand the question. So here we have to find fc of e to the power minus s. So fc means we have to find Fourier cosine transform. E to the power minus x is there. So function is what? Here function is e to the power minus x. But what is the domain of x? So if in this problem or this type of problem, if domain is not given, then we have to assume that what? X lies between 0 to infinity. Okay. That means x is defined over positive real line. Okay. Now we have to see how to solve, because till now we understood the problem clearly, how to do. What to do. Now how to do we have to see. So Fourier cosine transformation formula fc, okay, is given by this 2 by pi times, okay, integration from what? 0 to infinity f of x cos wx dx. So if you know this formula, it's well and fine. If you don't know, then you go to the lecture 1, lecture 2 of this Fourier transformation playlist and see how this formula came. You will understand clearly. So fc will be this. Now here we have to replace the function f of x. Now how to replace and what is the function, that we have to see. As I told, f of x is e to the power minus x and it is defined over positive real line. So positive real line 0 to infinity is there, so no problem, we will write 0 to infinity. But in place of f of x, what we have to write? E to the power minus x cos wx, so dx. Now before applying this integral or formula, we need the formula that let we have integration e to the power ax cos bx dx. So what is the formula for that? The formula is e to the power ax divided by a square plus b square whole into, so cos bx is there, so b cos, sorry, not b, this is a because the exponent is here a, so a cos bx plus b sin bx. So this is our formula. Now this formula we have to use and find out the integral, and there will be a constant term because here we are taking the formula for indefinite integral. So definite integral, the constant term will not be there. So what will happen now? Here if you see, in place of a, what is there? Minus 1. In place of b, what is there? W. So we have to apply the formula. Now it will be square root of 2 by pi, okay, whole into what? This formula. So e to the power ax, so a is minus 1. So e to the power minus x divided by a square plus b square, minus 1 square will be 1, w square will be w square. So 1 plus w square whole into what? A cos bx. So a is minus 1. So minus cos wx plus b sin bx. So b is w. W sin wx. So now close the bracket and the limits will be from 0 to infinity. So now what will happen? We will see square root of 2 by pi whole into, now if I see e to the power minus x in place of x, if I write minus infinity, then what will happen, that we will see. So first you write all those things, okay. So inside the bracket you keep it same, cos wx plus w sin wx, okay, minus e to the power what? We have to put 0, So e to the power 0 by 1 plus w square whole into minus cos 0, okay, plus w into sine 0, okay. So this thing. So you can ask me that why we are not putting here the value of x as infinity, because if I put this factor x value infinity, so e to the power minus infinity will be 0, so the whole term will be 0, so no need to put x value in inside bracket terms, okay. But the second term will be what? Minus e to the power 0, e to the power 0 is 1, okay, so that will write, so square root of 2 by pi whole into e to the power 0 is 1, so minus 1 by 1 plus w square whole into cos 0 is what? Cos 0 is 1, so minus 1 plus w into sin 0 is 0, okay. So w into 0 will be 0, so no need to write. So finally what will happen? This minus into minus will be plus, okay. So we'll get square root of 2 by pi into 1 by 1 plus w square. So this is our answer, or this is the Fourier cosine transform for this function e to the power minus x.